Hey, Kat here to talk more about arrays. This time we're looking at sorting arrays. So if it was a number array, we would look at sorting it into ascending or descending order. If it was a string array, we might be looking at alphabetical or reverse alphabetical order. So let's have a look at something called bubble sort. On the left of our screen, we've got the array that we've been using for searching strings and basic arrays. Then we've got an integer variable called hold, and on the right of our screen we've got the code that will allow us to do a bubble sort of this array. Now there's a while loop around the outside that allows us to loop through every array item, and then once we've gone through every array item we set finished to true. However, inside that we've got a for loop that also allows us to go through every array item. The loop inside the loop allows us to do a set of comparisons and bubble something down the list until it's at its right position. But if we do that just the once, then we don't end up with our items in the right position at all. We end up with a half sorted array. Okay, so if we go into our loop, first of all, we haven't finished yet and we haven't hit the end of the array. So then we go into our for loop. I is 0 and I plus 1 is 1. So this if statement here says if list at 0 is greater than list at I plus 1, we're going to switch the two around. So 6 is not greater than 7, and that if statement finishes, nothing happens, and it pops back up to our for loop there and I increments to 1. So now we're looking at if list at position 1 is greater than list at position 2, we're going to switch them around. 7 is not greater than 9, so we don't do anything, and our I increments then to 2. We're now saying, is the item at position 2 greater than the item at position 3? Is 9 greater than 12? No, it's not, so we don't do anything and we increment our I again. We're now looking at positions 3 and 4. Is 12 greater than 4? Well, yes, it is. So we take the 12, so if we're looking at this line here, we take the 12 and we put it into hold. The next line says that we take what is in the position of I plus 1, so 4, and we move it up to position 3. That last line there says to take what's in hold and move it down. Okay, so we've finished that little loop. Our I was currently equal to 3, and 3 is list.length minus 1. So we increment our I becomes 4, and that is false. So then we go down to this bit here, and it says if j, which is the loop counter that I've used for a while, if that is equal to the list length minus 1, so if that's equal to 3, then we're finished. But it's currently equal to 0, so we're going to increment it to 1. So j is now equal to 1. And we go back up to the start of our while loop. Is finished false? Yes. And j is less than the length of the list? Yes, that's true. So we're going to pop in and do our while loop again. So let's have a look. And we're comparing 0 and 1 again. Is 6 greater than 7? No, it's not. So we don't do anything in the if, and we loop back up to our 4. We increment our I to 1. Is 7 greater than 9? No, it's not. So again, we don't do anything. We then compare the next two. Is 9 greater than 4? Yes, it is. So we move the 9 into hold. We move the 4 up a position and we move the 9 back out of hold. We've then completed that if statement. We increment our value of I. Is 9 greater than 12? No, it's not. And now we've finished that for loop because I is now 3, and that is list.length minus 1. It's no longer less than list.length minus 1. So we go back down to our if statement down the bottom. If j is equal to list.length minus 1, j is equal to 1 here, so that bit's false. We execute the else and we increment our j to 2. Then we're going to go back up to the top of our while, Finished is still false, and j is still less than the length of the list, so we'll pop back into our for loop. So again, we do our comparisons. You can see that slowly that number 4 is bubbling its way up the list, and that's why this is called a bubble sort, because the items bubble their way into position. The idea of this looping is we basically have to do a while loop to loop through every array item. But then we have this second loop to bubble through each item in the array as well to get that bubbling effect. If you only had one loop, one number would move its position probably, and the rest wouldn't do anything. So that's why you need the double loop. Okay, so where we're currently at, we are comparing, we're up to j is equal to 2, and we're comparing 6 and 7. Is 6 greater than 7? No, it's not. Is 7 greater than 4? Yes, it is. So we move 7. Woo! Sorry about that. Back to normal. Okay, so we said that 7 is greater than 4. We move our 7 into hold. We move our 4 up, and we move our 7 back out of hold. Then we loop back around and we say, is 7 greater than 9? No, it's not. Look at the next pair. Is 9 greater than 12? No, it's not. And we're going to finish that if statement inside the for loop. That for loop has finished, and we're going to go back through and we're going to increment our j. Our j is now equal to 3. Sorry about the change in colour. And j is less than list.length. Finished is still equal to false, and so we're going to go back through that for loop. Okay, so is 6 bigger than 4? Yes. So we move it into hold, we move 4 up, and we pop 6 down. Is 6 greater than 7? No. Is 7 greater than 9? No. Is 9 greater than 12? No. Okay, so our for loop is finished, and we're asked if j is equal to list.length minus 1. Now list.length, it is equal to 5. So remember that you count 0. So there are 5 items there. 1, 2, 3, 4, 5. List.length minus 1 is equal to 4. We're not currently there yet. So we increment and we do this j++. That means that our j is now equal to 4. So let us continue. Finished is still false. J is less than list.length. Let's go back into that for loop. Is 4 greater than 6? No. Is 6 greater than 7? No. Is 7 greater than 9? No. Is 9 greater than 12? No. So we finished that internal for loop. If j is equal to list.length minus 1, we are going to set finished to true. Okay, so finished is now true. That's wrong. So for this while loop to happen, both of these things must be true, because one of them is no longer true. That means that we finish sorting the array and everything is done and we can continue on with our code. So sorry, that might be a little bit of a scrappy version, but let's implement this code, and we're going to use drawstrings before the sorting of the array and a drawstring after the sorting of the array, just to check that it has actually done what we think it's doing. Okay, so let's go to Eclipse and have a look. Just in Eclipse, in my arrays project, I've created a new file called sorting arrays. So first of all, one of the things that we need to be able to sort an array is the array itself. So I'm going to create an array called list. I'm going to not use the one we just used in the example, but I'm going to use something bigger. So I'm using 8, 5, 64, 15, 2, 1, minus 3, 0, 42, and 99. Just a nice little bit of variety there. Now our while loop used a variable called j that was counting how many times we had gone through the loop, and we also had an integer called hold. We're also going to need, for printing out our content to the screen, we're also going to need to have a variable to change the position on the screen, and I'm going to use xpos for that. And we also needed a Boolean to determine whether or not we had finished sorting our array. So that one starts off at false. Also, based on experience, I'm going to set the screen size, so I'm going to make it fairly wide because I'm going to print out the entire contents of that array across the screen. So I'm just setting it up ready to go. And the guts of this goes into Paint. So first of all, declare all the variables that you're going to need. You need your array, a loop counter for the while loop, a variable to hold the value as you move it through the array, and an XPOS to be able to print out the contents, and a boolean for finished. Okay, so looking at Paint, let's first of all just have a look at the contents of the array. So I'm just going to put a comment there to indicate what I'm putting on the screen. So I'm going to say that this bit of code will display the contents of the unsorted array. Okay, so to display the contents of an array, we usually use a for loop. So int I equals 0, continue looping while I is less than the length of the list, and increment by 1 each time. Then I'm going to have a g.drawString, and because the array is an integer array, I have to give it a dummy string. And then I'm going to print out list at position I, and I'm going to print that at xpos, comma 20. Then remember, if I'm using an xpos, I actually need to change the value of xpos, otherwise they all end up on top of each other anyway. So I'm going to have xpos plus 20. So let's just quickly run that and see what our array looks like unsorted. Okay, 8, 5, 64, 15, 2, 1, minus 3, 0, 42, and 99. Now the uneven spacing for that is that some numbers take up more room than others, and by incrementing my xpos by 20, I'm not saying plus 20 from the starting point of the letter, I'm saying plus 20. Sorry, I'm not saying plus 20 from the end point of the letter or number, I'm saying just plus 20 from the last value. So they end up at weird spacing. Anyway, let's now have a look at sorting the list, or sorting the array. So as we said, we've got a while loop, and that while loop, so open bracket there, not curly brace, our while loop will continue while finished is equal to false, and while j, so our outer loop counter, is less than list.length itself. Okay, so there are two conditions for the loop to continue. Finished is false, and j is less than the length of the list. So we don't want it falling off the end of the list. Okay, sorry, I'm not brilliant with my words today. So inside there we've got our for loop. So for int I equals 0. So our stock standard for loop, except, so I is less than list.length minus 1. Now we've always used list.length, not list.length minus 1. However, in the if statement that is to come, it compares the value that we're looking at to the one ahead of it. So if we're at the end of the array and we try to look one item further, that doesn't exist, and we get an error, and that's called an array index out of bounds. So if you ever try to access an array item that does not exist, you will get that error, and your code will not run correctly, and it may not run at all. So because this particular piece of code is looking ahead, we have to use the minus 1 there. Okay, so if we're asking if the first array item is greater than the next one, I plus 1, where are we? So if one array item is greater than the next one, we want to swap their positions. So we set hold to the one that is higher up in the list. Then we set the one that was higher up in the list to the one that was below it. And then we replace that one below it with the one we took out of the first gap, which is currently in hold. Hopefully that makes some sense. Okay, so it's basically just switching them around. Now, that will check every array item. So it'll compare 0 against 1, 1 against 2, 2 against 3, 3 against 4, all the way through once. And then we said that we need to, after we've done that, we need to start again and we need to go all the way through the array again. So we need to go through the list length times the list length, basically, so the double for loop. But we do need to have something in place that allows that outer for loop to increase its value. So we're asking if that outer for loop counter is at the end of the array. So if that is equal to list.length minus 1, then we want to set finished to true. But if that's not the case, we just want to increment that counter with J++. Okay, so let's just run that. And we've still got just the array as before. I was looking down here. I've got no errors popping up. So what I'm going to do is, so that I can see the sorted array, I'm going to copy that piece of code at the top that display the contents of the unsorted array. So I'm going to copy that. After sort the array, so you look where this bracket starts and it ends. After that, paste it in, and we're going to display the contents of the now sorted array. I'm going to pop that further down the screen, and I will set my xpos to 20. Now I'm setting it just before that for loop, because if I didn't set it to 20 there, it would continue the values from up here and it would end out far to the right of the screen. So I'm just going to reset xpos to 20 there. And let's have a run and see. So here's my unsorted version and my sorted version. It would be quite clear that I never set xpos to 20 for the first array there because it's further left. And that has worked brilliantly. So it's gone from the negatives through the zeros and up. I'm just going to quickly set this xpos to 20 as well, just because I like things looking neat. And I'll just point out this little symbol right here where you're comparing the two values. It's basically saying you want to swap the two values if the first one is greater than the second one. But there might be cases where you want to do it the other way around. So if you say if the first one is less than the other one, so if we want to go in descending order, you just switch the little symbol. So let's run it and we should get the opposite. Okay, so this is the unsorted and then the sorted. So changing the direction of the symbol will allow you to sort ascending or descending. Okay, there we go. So that is a basic bubble sort. Okay, quickly looking back at the exact same code that we were just working with, I've made a duplicate of that and I've called it sorting string arrays. So we've looked at sorting numbers, let's look at sorting words. So I'm going to change my list to contain strings. Let's just delete those. And I'm going to just pick some animals. So I'm going to have cat, dog, mouse, frog, whale, bee. Make sure that each word is in double quotes. There we go. Now, the variable used for the switching of the places, that also needs to change to a string. So we've got it almost set up for a string. Now what we're going to do is, because words are wider, we'll change our xpos to increase by more each time. So in both of my sections of code that deal with the output, I'm just going to change them to xpos plus 40 in both cases. And here we've got an error. So I've dealt with how it's going to print out, all that kind of jazz, and change the data types. Now I'm going to look at the guts of it, which is the loop that sorts it. The only place that's giving an error is in that comparison, which is asking if the previous list item is bigger or smaller than the next list item. And that's because we can't use a simple comparison operator for strings. What we need to do is we need to say if the first item dot compare to, and put the other one in the brackets, and that will compare the two values. That's still an error, but that's okay, I'll fix that in a moment. What compare to does is it looks at the numeric value of each of those characters. Okay, now I know from experience that a capital A is 65. That would mean that a capital C is 67 and a capital D is 68. So based on those numeric values, it checks by subtraction which one is alphabetically before the other one. So if it is greater than 0, I always get these back to front, but if it is greater than 0, then the earlier item comes before the second item. So you need to do the compare to one item compared to the other item. If that is greater than 0, you're going to switch them around. So let's just run it. Let's see if I've got them the right way. Okay, so bee, cat, dog, frog, mouse, and whale. So I could probably bump that out to 50 just for appearances. And this has done the correct comparison. Now if I change the directional arrow, it should put the alphabet into reverse alphabetical, so whale, mouse, frog, dog, cat, and bee. So, as I said, compare to compares the two, and it gets it and decides the value based on the numeric value of the characters. It does it by subtraction. If the difference is less than 0, then the second one is before the first one. If the difference is greater than 0, the first one was before the second one. Compared to is a bit confusing. I usually do it by trial and error because I always forget which direction I need to test against. But that's why programming is so fantastic. Especially with this case of scenario, you can just change the direction of the symbol and get a different result, ascending or descending. So that was a quick look at how you would sort a string array as opposed to a numeric array.